Okay, let's learn how to graph cosine now. Okay, so we need to graph y equals negative 2 cosine 3 theta. So same thing we're going to do is start with finding where all of the important things are, okay? Important aspects of this graph. So let's see, we always want to start with the amplitude. Amplitude is how high or how low something goes. It's just like absolute value, right? If I go down or if I put my car in reverse, I'm still traveling that distance. So even though this is a negative, my amplitude is just 2. The negative tells me what my function is going to look like. So we know that a regular cosine starts with a c, right? So then it looks like this guy, okay? But with a negative, all that means this is a positive cos. Negative cos, we're just going to flip it. So instead, my negative cos is going to be like this. And then, like I said on the last video, I always draw a quick little sketch of what this thing is supposed to look like because it gets confusing when you have this weird looking graph, right? This weird graph with a bunch of dots. Now what? Okay, so this is what we want. Amplitude 2, negative, is just telling us our function is upside down or reflected around the x. Okay, next thing we want to do is find our period. Remember, our period for sines and cosines is 2 pi or 360, and we always want to divide it by the number with our theta. So in this case, it is 3. Do you know what 2 pi over 3 is in degrees off the top of your head? If you do, awesome. If you don't, I don't know. I'm going to do that quick. So I know 2 pi is 360. 360 divided by 3 is really 120 degrees, just so I can get a better idea of what this really is, right? Because like I said, I don't think in radians naturally, but I can think of 120 degrees. That's okay. All right, now we want to figure out where something important is happening. Something important. Okay, so remember we're going to take our period and we always divide it by 4. So in this case, our period is 120, or let's be really crazy here and take our period, this guy, and divide it by 4. So 2 pi over 3, that's going to be our whole numerator, and we're dividing it by 4. How do we divide a fraction into a fraction? Well, remember this is a numerator or a denominator of 1. We're just going to multiply it by the reciprocal. Goes away. So we get 2 pi over 12. 2 and 12 cancels out to be pi over 6. Pi is 180. 180 divided by 6. So this is the same thing as every 30 degrees. Okay. All right, so something important is happening every 30 degrees. If I look at my lovely graph, we got pi over 2 and pi, and then I don't know what all these other values are. So let's go ahead and look at how many we have between 0 and pi. So we got 1, 2, 3, 4, 5, 6. So 6 units between 0 and pi, which is a sixth of pi, which is really 30 degrees. So something important is happening one of these grid lines is 30 degrees, which is how often something important is going to happen. So that's kind of convenient. Okay, so we are going to start with our starting point. And then I'm just going to redraw that little graph that I had on my other paper for you. It's a negative cosine, so we know it's going to look like this. So here's my start, okay? And then we want to figure out where our endpoint is. Amplitude is 2, so we're just going to go down 2. Okay. My endpoint is going to be the same location, just shifted out. My period, which I said my period was 120 degrees, or 2 pi over 3. 2 pi over 3 is not marked on our lovely thing, but we can go out 120 degrees because we know each of these marks is really 30 degrees. So 120, so that's 30, that's 60, that's 90, there's 120 degrees. What does this 3 really mean? that 3 really means where we would normally have 1 period, right? That would be 1 full period. We are going to have, let me see if I can draw this. 1, 2, 3. We're going to have 3. That's so even and beautiful. We're going to have 3 full periods within where we would normally have 1. So that's okay. This looks very small, which is okay. It makes sense if you really think about what the graph is, the end graph is going to look like. Okay, so after we have started by plotting our start point, we plot our end point, and then what do we plot? We plot our middle point. So halfway between this, you guys could just think of these as units, right? This is 1, 2, 3, 4 units. What's halfway between 4? 2. So now we know our high point is going to be, because then we're talking about a cosine graph. So we know this is our start point, this is our end point, and then our middle is going to be up high. So 2 points out is fine, two units on your graph paper. And then we're going to go up our amplitude, which is 2. Okay, then where is the halfway point between the start and the middle? That's going to be on the x-axis this time. So halfway between 2 units is 1 unit. Halfway between 2 units is 1 unit, which we said 1 unit is equal to pi over 6 or 30 degrees. And we said something important is happening every pi over 6 or 30 degrees. So this makes sense. Okay. So let's see. The graph goes to a normal period is between 0 and 2 pi, right? And we know that this is just a pattern. We know that this means there should be 3 cycles in 360 degrees or 2 pi. So let's see if that's true. Let's just keep repeating this pattern. So we have low, center, high, center, low, and we go out 1 point, center, out 1 unit, high, center, low, center, high, center, low. Okay, let's graph it. Here's 1 full cycle because I was starting low and then going up. I'm low and now I'm going to be going up. Oh, let's see how confusing I can make this with all my colors for you guys. And then we're going to go, there's another period. Oh my gosh, we have 3 full cycles in what is normally 1 period, which is exactly what our graph says. Our equation says. It's a negative. That's definitely a negative cosine. It goes up 2 and down 2, so that looks good. And then we can continue our pattern of every 1 unit, there's a dot, and so on. It goes on indefinitely, right? So we can do the same thing over here. Every 1 unit is a dot. So our graph continues, making it a smooth curve. No jaggedy lines. Okay. And that is how we're going to graph a cosine function. Don't worry, we'll do lots more of these. I know this is very confusing. And always, guys, if we're not giving you enough examples and you still need more help, Google, YouTube. There's tons of it. All right, we'll see you next time.